Welcome back to the FastAPI Backend series. Right now, our API works. It connects to the database, it validates responses, it has structure, but it's wide open. Anyone can call it, anyone can access business data. That changes today. In this episode, we add authentication to the API. But before we do, let's explain why authentication matters. So if we go back to our FastAPI documentation, which is basically Swagger, and if we open our endpoint sales version 2, for example, we'll see that when we execute, we get our data here. But it's without any restrictions. We didn't have to do anything. Anybody could just come in here and then click execute, and it returns the data. This is fine in development, but in production, it's a liability. Real systems protect data. Users must prove who they are. Authentication is not optional. Security is part of backend engineering. An unsecured API isn't a feature, it's a vulnerability. And that's why authentication matters. Before we implement authentication in the API, we need to install a couple of dependency libraries to the project. One to store passwords safely, and the other to create secure tokens. The first one, FastLib-bcrypt. FastLib-bcrypt is commonly used in authentication systems, especially in FastAPI apps, and is used to securely hash and verify passwords. We never store passwords, not in plain text, not in encrypted, not hidden. We store a one-way cryptographic hash. Python Jose is a library that is mostly used to create and verify JWT tokens, especially in authentication systems, very common in FastAPI apps. JWT stands for JSON Web Token and is a compact URL safe string used to securely transmit information between parties. Most commonly used for authentication and authorization in web applications and APIs. Now let's jump over to VS Code and implement our password hashing module. Let's first install the FastLib-bcrypt dependency library by going to terminal, and we'll use the pip install command, and we'll use the name of the library here, bcrypt. And then hit enter. But before we do, what is bcrypt? Bcrypt is an adaptive hashing algorithm designed specifically for passwords. It's slow by design, and that's a good thing because the key principle behind password hashing is not about speed, but about making guesses for hackers slow, expensive, and painful. So we got pip install FastLib-bcrypt. We hit enter. This will install our first library here. And then let's go to our files and then go to the requirement text and make sure that we enter it here. This is necessary for deployment purposes to allow deployment environment to install the exact packages that we need for our project. So type underneath here, pass lib bcrypt. We'll save our file. Now we're ready to create the authentication module. So let's go back here and we'll create a new file. So we'll use the touch command and we'll create it under the app folder. We'll call the new file auth.py. And this file will be the module file that handles password security. So this will create an empty file for us. If we go to under our app and then open our auth.py file, now we can start coding for our module. So here is the code for our authentication module. As you can see here, it contains two functions, a hash and a verify, and that's it. Basically, hashing is a one-way mathematical transformation. You input a password, you get back a complete different string. There is no reverse. You cannot decode a hash. So what we're doing here with crypt context, we're basically importing a tool that knows how to hash and verify passwords safely here. Crypt context is basically a manager. It handles which hashing algorithm we use, how passwords are hashed, and how they are verified later. It basically saves us from writing dangerous crypto codes ourselves. Here, we are configuring our password system to use bcrypt. We are choosing bcrypt as our hashing algorithm. If we ever change algorithm in the future, FastLib can automatically mark old ones as outdated and upgrade them when users log in. Think of this line as set up our password security rules. In here, where we're defining hash password, all we're doing is taking a normal password and turning it into a secure hash. When this runs, bcrypt generates a random salt. It applies a slow hashing algorithm. It returns a long scrambled string. And in this part of the code, we're defining a function called verify password. And basically it's checking if the password the user entered matches the stored hash. Internally, user enters password at login. We take the stored hash from the database. Bcrypt reads the salt and settings from that stored hash, and it hashes the entered password the same way. It compares the result. If they match, it returns true. If they don't, it returns false. We really never decode the hash. We just test whether the input produces the same result. In general, the module basically sets up bcrypt as the hashing algorithm. It provides one function to hash password. It provides another function to verify passwords. And it ensures passwords are never stored in plain text. That's it. Now it's time to test this module and what we have so far. So let's save our file, and then we'll clear out our terminal, and then we'll use the Python shell, and then we'll enter this line here from app.auth import hash password. This will work because our app folder is actually a Python package. So if we hit enter here, now we can run the hash password function, and we'll pass it in a string like super secret 123. Then we'll hit enter. If you get a crazy error that says password cannot be longer than 72 bytes, it is an unknown compatible issue between fastlib and bcrypt, especially with the newer versions. And your password super secret that we put in is not exactly too long. That error is just a side effect of the backend failing to load properly. So to fix this, what we'll need to do is get out of the Python shell. We can do exit. And then now that we're back to the our environment, our Python environment, we can enter the following command. But let's clear out the screen so we can see this better. So we'll do clear terminal, and then we'll do pip uninstall bcrypt -y, and then we'll do pip install bcrypt equals double equals 4.01 to install that version. Okay, next we'll try this again by going to Python. Then we'll inherit the hash password again from our app.auth, and then we'll run and use the hash password function, and then now we get our hashed password, long string, long random string. So we'll run it again. And we get another string, but different output. Same password, different hash. We use the same password, but we get two different hash strings. That's because bcrypt automatically generates a salt. That means even identical passwords never produce identical hashes. That prevents rainbow table attacks. Now, while we're still in the Python shell, let's test the verify password function. So we start off by importing it. We'll change this to 5 password. We'll just hit enter. And then we're going to set a variable hashed equals hash underscore password super secret 123, and then hit enter. So now this hash variable holds that string, that hash string, random hash string. Now let's do a verify underscore password. And then we'll pass in the super secret 123 password that we had set up. We're just verifying to see. And then we'll compare it to the variable that we just created, hashed. Then we'll close the parentheses and hit enter. And it throws the error, name error, because we typed this one. It's verify underscore, not verify dash. So we can go back and correct this. And underscore, fix that. And hit enter. We should get true, because we're comparing super secret with hash, which is true. Now, if we were to do the opposite of that, put in like a different string, we should get false. Wrong password. And then if we hit enter, we should get false. So our module is working as expected. We never compare plain text. We verify against the hash. If the database leaks, attackers don't get passwords. They get hashes. And properly hashed passwords are computationally expensive to crack. This is baseline security. Okay, now that we know how to secure our passwords, we need a way to prove identity statelessly with no sessions and no server memory. We want something portable. We want JWT, aka JSON Web Token. First, let's install the JWT dependency Python Jose library. So let's exit the shell. We'll do exit. And then now we're back to our Python environment here. And let's clear the terminal so we have some space. And then now we can install the dependency Python Jose cryptography. We'll hit enter. Our installation is complete. Now let's make sure that we add that to the requirements.txt file. We'll place it right at the bottom of the file. We'll save that. Again, JWT stands for JSON Web Token. It's a signed payload that proves identity. The server creates it, the client carries it, the server verifies it. No state, no memory, just trust the signature. We're almost ready to start creating our JWT module. But just before we do, let's add some environment variables. If you recall, in episode 3, we discussed environment variables. So if you need to refresh on that, you can check out episode 3 of this series. So let's go to our env file, and we're going to add some environment variables that we're going to need for our module. If you recall, in episode 3, we had our database URL environment here, set here, and then now we're adding those 3 here. We have a secret key that we're setting to your super secret key. Change this. So you want to change this in production to a long random key. Never hard code secrets, especially not your signing key. In production, again, this must be long, random, and secure. And environment variables keep secrets out of your code base, pretty much. The algorithm HS256 tells your app how the JWT should be signed. In simple terms, when the server creates a token, it digitally signs it. The algorithm decides how that signature is created. The access token expire minutes. Basically, once issued, this token works for 30 minutes, and after that, it expires. In short, that config basically is saying sign tokens securely using HS256 and make them expire after 30 minutes. Now we're ready to create our token module. So let's clear out our terminal, and then we'll create a new file called token.py. So we'll use the touch command, and we'll put this under the app folder, and then the name of the file again is token.py. Then we'll go to that file and open it, and then we'll add the JWT code for this module. And here is the code to handle JWT creation and verification. It contains 2 functions. The first one is create access token, which will generate a signed JWT token. And the next function will be verify access token, and that one will verify JWT token signature and expiration. It will return a payload dictionary if valid, else none. First, the code is loading the variables from the .env file, and next it's reading these values from the environment, and the values that we need are secret key, algorithm, and access token expires minutes. Create access token, create a function that takes some user information, for example, user ID or email. Then it makes a copy of the user's data so we don't accidentally modify the original. Then it calculates when the token should expire, then adds the expiration time into the token data. EXP is a special JWT field that means this token expires at this time. Then it creates the actual JWT takes the data, sign it using your secret key, and then use the chosen algorithm like HS256 and return the finishing or the finish token string. The verify access token create a function that takes a token along JWT string as input. Then the line here does several things at once. It verifies the token signature using your secret key. Then it used the expected algorithm like AS256. Check if the token has expired based on the EXP field. Then extract the data stored inside the payload. If all checks pass, then the decoder user data is stored in payload and returns the payload. If the token is valid, you get back the data inside the token like user ID or email. This means that the user is authenticated. If anything goes wrong, the token was modified, for example, or the signature doesn't match, or the token has expired, or the token is completely invalid, then the catch error part here would return none. Now, the JWT workflow here is that we create a token after login. The token carries identity. It's signed so the server can trust it. If the token is invalid, if it's expired, access is denied. Important production note here. For real deployments, use a strong randomly generated secret key. Store secrets in server environment variables and never commit the .env to version control. Now that we can securely store passwords and create JWT tokens, it's time to bring them together. We will check the user's password, and if it's correct, hand them a token. All of this happens in a brand new endpoint called login. So let's head over to the main py file and add our new endpoint. Before we code the endpoint, let's add some imports that we're going to need. Okay, we've added HTTP exception, and it's used to send error responses like 401 unauthorized errors. We also added auth2 password bearer, which tells FastAPI that this endpoint uses auth2 with password flow. It helps with handling tokens. We also added auth2 password request form, which basically parses incoming login form data, giving us username and password automatically. And from our own modules, we're importing the hash password, which converts a plain password into a hash secure password. We also have verify password, which checks if a plain password matches a hashed password. We're also adding create access token, which makes a JWT token that the user will receive if login succeed. And then we also added verify access token, which checks a JWT token later when the user accesses protected routes. And those are all coming from the two modules that we added for this project. app auth and app token. Next, we'll add this line, and it will set up a standard auth2 password flow. It's basically telling FastAPI that when someone needs to get a token, they'll call \login. This is important for endpoints that require authentication later. FastAPI will use this to extract tokens automatically. Next, we set up a fake password or fake database. And basically, this is just a mock database. In a real app, you would want to query a real database. Admin is the username, and hash password is we never actually store plain passwords, so we're using the hash password function here to hash our password, which for now we're calling admin123. So we never store plain passwords, only hash versions for security. Think of it as a practice database for testing login functionality. Next, we define the login endpoint. We'll go right below the sales version 2 endpoint, and we'll define our new endpoint called login. Notice that this is a post endpoint, and form data, this line here, FastAPI automatically reads the form fields from the request and provides the username and the password. This is what the user sends when they try to log in. This line here, fake users DB, this line here checks the database, in this case the dictionary fake user DB, for a user with that username. If the username doesn't exist, user will be none. To handle invalid username, this line here or this part here, if the username isn't found, stop the process. Send a 401 unauthorized response, detail invalid credentials, a safe message that doesn't reveal which part was wrong. In this line, verify password checks whether the password the user typed matches the stored hash password. If it doesn't match, then it's stop and return a 401 unauthorized. Important here, we never tell the user wrong password or user not found. This prevents hackers from guessing usernames. Here is where we're creating a JWT access token. If login succeed, we create a token. Create access token handles adding expiration time, signing the token with a secret key, and returning a secure string the user can use to access protected routes. Think of this as handing the user a digital key that proves their identity. So what you end up getting as a response is a JSON formatted string with the access token and the token type, which will be bearer. In general, the overall flow is 1. User sends username and password to \login. 2, server checks if the username exists. 3, server checks if the password is correct. 4, if either fails, it rejects with a 401 error message. 5, if both succeed, it'll create a JWT token with user info inside. 6, it returns the token to the user. And 7, user can now access protected routes by sending this token. In short, verify credentials, issue a key, and let them in, all in a secure, stateless way. I've just noticed that we are using this import here from FastAPI security. FastAPI requires that we install Python multi-part dependency if we're using this. So we need to install an additional dependency for this auth to password request form. So let's install the multi-part dependency. So to do this, we do it in our environment, and we use the pip command, pip install, and then hit enter. We also need to update our requirement.txt file and add this Python multi-part dependency here. And then now we can file and save all our work here. At this point, we are ready to check our login endpoint. So we'll use Swagger, the UI, to test this. So let's run and debug this. It's running on this port 8000 on the local host. So let's jump to a browser and see what our login endpoint looks like. So at our browser, if we go to our docs, which is basically Swagger, and let's maximize this so we can see it better. Here's our new endpoint login, and if we play around with it and look at it, and you can see what the auth to password request form looks like from our code. And as you can see, it requires basically a username and a password. So let's try it out, and then we'll key in the fake username and password credentials that we had set up in the code, which was admin and admin123, and then scroll down a bit. That's all the required fields that we need. And then we'll click on execute. And we should get a token, an access token, as well as the type. So our response type is a 200, which means it succeeded. And we got an access token here. So this is the token that's going to allow us to provide security, securing our endpoints. And the type is bearer. And if we were to enter wrong credentials, for example, instead of admin123, we enter anything else and click execute, we should get a 401 error unauthorized, invalid credentials, which is what we expected based on the code that we have for our login. If we return back to our code, you can see here our 401 for invalid credentials and 200 or a success if we get the right, if we enter the correct credentials which we faked up here in our fake user DB, which was admin username, and the password was the hashed admin123. And this is the result that we would expect: access token and the token type based on our login endpoint. So far, we have secured passwords. We have JWTs. We have a login endpoint. Now, let's protect something. For example, we got the sales version 2 endpoint here. Let's protect this endpoint so that only authenticated users can access this route. To do this, we're going to create a new function called getCurrentUser. Let's add this code in the main py file, and we'll place it right under the fake users DB section. So just here's the code to our getCurrentUser function. Basically, this function checks the user's token, and if it's valid, let them through. If it's not valid, stop them. Think of it like a security guard at the door. Now let's use this function to secure our sales version 2 endpoint. To do this, we're just going to add this line or this piece of code as a parameter to our get employee sales definition. So it's basically current user dictionary equals depends get current user, the name of our function. So when someone calls this endpoint, FastAPI extracts the authorization, which is bearer. It's the bearer header. And then the auth2 scheme grabs the token. The auth2 scheme is from our getCurrentUser function. And then getCurrentUser function verifies it. If invalid, it'll throw a 401 unauthorized error. And if it's valid, the endpoint will execute normally. To test this, we can use our Swagger UI doc and see if the endpoint is actually protected. So let's jump to a browser and see what we have. But first, we run our debugger. And make sure that we can go to the 8000 port on our local host. At our browser, let's go to our UI, Swagger UI, and let's maximize the screen. And let's take a look at our original sales endpoint. As you can see, we can get to it without any restrictions. Here's the data. Now, if we try to go to our version 2 of the sales, if we try to get to the data, we'll get a detailed info that says not authenticated. So we can't get to it. It's not authorized, a 401 error. So our endpoint version 2 is protected. whereas the original one is not protected. The sale one is not protected. So if we want to use sales version 2, based on the code that we created, we can use in Swagger, we can use the authorize button here and then enter our credentials, and this will create a token for us, a JWT token for us, given the correct credentials like admin and admin 123, which is the fake credentials that we created in our code. So we can authenticate this by clicking the authorize button. And then now we should be able to, let's close this pop-up. Now we should be able to execute version 2 of the sales to see it. So if we click on execute here, as you can see, it gives us on the header here, the authorization bearer, and this is the token that it created for us, as well as the data. Now we can access the data with the credentials that we provided. If you notice, we're using no sessions here, no state on the server, just a signed token the server can trust. The client sends the token on each request, the server verifies it, and access is granted only if everything checks out. This is the backbone of stateless API security. We're using Swagger here as the UI. It's a very nice tool to use, but if we can replicate this in a front-end application, for example, an Angular or a React front-end, which we would pretty much do similar things that we're doing here. All we need is to get the token so we can access data for the front-end app. Stay tuned. I probably will create a series on a front-end using probably React or Angular. So make sure to subscribe so you don't miss out on that one. So the complete flow recap here is user signs up, password hash, user logs in, password verified, JWT is issued, client stores JWT, client requests protected root, tokens verified, access granted or denied based on validity. So we now have a fully functional, secure authentication system. Passwords are safe, tokens are signed, protected roots enforce security. This is modern API authentication in FastAPI. So what did we achieve here? We hash passwords, we generate signed tokens, we verify identity, and we protect roots or endpoints. This is the minimum bar for real APIs. The database stores data, the API exposes data, authentication control access, security is a layer, not an afterthought. Now let's go back to our code and commit this for this episode. Just click here and we'll put a comment in here. So episode 6, we added JWT authentication and secure endpoints. We'll commit this and sync to GitHub. And that's it for episode 6. Right now, our API is secure, but it only lives on our machine. Real systems live on the internet. On the next episode, we'll deploy this API to the cloud for free. We'll use a free tier cloud provider called Vercel. You'll have a live production URL accessible from anywhere because a backend isn't real until it's reachable. I'll see you in episode 7.